everybody. Can we maybe close the door? That would be nice. So let me quickly introduce myself, and I'm glad you made it to here. I had just to adjust the slide deck if there is any small mistake. Totally my fault, because I was thinking the Beamer has more power, so I had black with white font. Now it's white back and black font. So, okay. I'm a senior software engineer at Airalo. Airalo is a small company, and we're providing eSIMs if you want to travel maybe outside of Europe. We are the way to go. And if you might see on the agenda, there's even more software engineers from us here today. Even right after this talk, there's another. And of course, also about AI. So this is what I do by day. I'm a strong believer in Kotlin multi-platform, even though this has nothing to do with the talk, so just you know that. And I organize some things in Berlin. So I do the Kotlin user group, I do the Extreme Tuesday Club, that's a formation of people which speak at least once a month about good practices and so on. And I also organized Unconference just 3 weeks ago, the XP Unconference. The topic there surprisingly was also AI, and I do much more things than that. So if you want to stay in touch, there is a big old QR code. You can add me on LinkedIn. I count to 5. 1, 2, 3, 4, 5. So everybody has. That's great. So what to expect from this topic or from this talk at all? First of all, it's not about prompting. It's not about coding. I will just make a high overview and will just explain the concept. I am currently in the making of a second talk where I go more in the practical part. But sadly, if I walk into talks these days, which speaking about AIs, they normally don't speak about foundations, they don't speak about practices, they don't speak about studies, which I find really regretful, because what is currently missing is also a very grounded overview about the topic and what's the state of research and so on. And this is an ever-changing talk. If you had been, for example, 2 weeks ago at DroidCon Berlin, forget what you've seen there, because I already updated slides and everything. So every time I make this talk, it's new, not from ground up. That happens only barely these days. But for instance, for this time, I switched out a lot of the first chapter with new stuff and so on. And the last thing is, if you're already doing something with software engineering, I want, of course, to encourage you to try it yourself, because in my observation, a lot of people are still very hesitant to do something with AI engines in their daily job, or even just to play around for a lot of reasons, like psychological safety, or because companies seem to say, oh, you have to use it, and people then say and shut off, no, I don't want to because you force me, and there's much, much more. So what is actually my incentive? Why I want to talk about this topic? First of all, I think laziness is a thing, right? We want to be as lazy as possible in our daily life. We want to be bored. We don't want to struggle. We want just to do our jobs and then enjoy our lives at the same time. So laziness is really a mindset. And this is also why I do something like TDD or extreme programming, because it actually helps me to be lazy whenever I can. The second thing is I want to shift and keep my focus on what's important. And the important part is normally not the coding itself, it's more about the business, right? It's about what you want to achieve with your software, what you want to achieve with other stuff, which problem you ever want to solve. It can be also in scientific research, right? But it's never about the coding itself. So this is when you are a beginner, if you want to learn languages, this is completely different. But once you are in a job or something over this initial part, then it's really about other stuff. So, and of course, and that's the weird part, it makes fun, right? If you play with new stuff, it's always fun because you learn new things. So what are my questions I have to ask about these topics, or which are more like a guideline or a guidance for me overall, over even the last 6 months? So first of all, how and if can AI models or AI tooling or assisted programming, however you want to call it, can augment the capabilities of software engineers? This is a very crucial question, because if you've seen the discussion over the last 2 years, it's always a given that it had been said AI will help you no matter what, right? Without even questioning it, even not asking how it can help and if it's helpful at all. And the second thing is like, what we are seeing right now is that something happens with programming. Programming itself is shifting in a sense to what we come later a little bit more in detail, and also what happens to some practices like test-driven development. So what's the future in there? Will it be still a thing? Will it be vanished or something else? And lastly, what actually that means for the industry. As you might have noticed, like in the last 2 years, aside from some economic struggling, especially AI is always used as an excuse to not hire, for instance, junior developers, right? Or don't give them a fairly chance. Because some companies have a very odd sense of mind to say, oh yeah, AI can replace junior developers, and that simply means junior developers are not actually more than people who code something which can be automated. And I think this is totally wrong, but we come also to that later. So this is why I want actually to speak about the topic. And of course, because I also want to speak about you, with you about that. So, and before I start, a little story. So like I started to get more involved with the topic like 1.5 years ago. And for me, like for others, it was at the time where I got really, really scared, because I have a lot of smart people in my surrounding, and they started independently from each other to say, oh yeah, I tried Cursor, and Cursor was so good, and it could actually do what I'm doing normally over a week in a day. And others said, oh yeah, I automated all my coding flow, so I can, or I don't have actually a need to maybe hire more engineers and stuff like this. And that really scared me, because for me, I thought always like having the capability to produce very high quality code, and also code which brings business value, is very important. And now somebody, maybe a business owner, comes and says, yeah, I don't need to really program anymore. And that honestly scared the shit out of me. So what becomes with me maybe in the next 10 years if those trend goes on? Because coding is something I really like, and what I'm good at, I think at least. So this is for me also the reason why I started to get into the topic. And that's why I also started to speak more with others, also to practice more with others, just to overcome this initial shock. I know that a lot of software engineers these days are still in this shock and not can move anymore. And that's really sad, because we should actually embrace what's currently happening. If we just stay where we are, the technology will go without or with us. That's just how it is. So that's what I wanted to say as an introduction. And then, of course, the question is, first of all, what is programming, right? So, and I would say programming is something which is not necessarily connected to code, but what we want to is we want to identify and solve some problems. It can be scientific problems, can be business problems, can be just day-to-day life problems, right? And normally we solve that with code. Why with code? That's also very important, because coding or programming languages have some very unique properties. Like they use a very precise language. If you have normally a natural language, it's very ambiguous. Like just this week, I was discussing with one of my fellow engineers if we just rename a stuff which was called card, because nobody knew what it meant anymore. Is it a credit card? Is it a SIM card? Is it a card in our design system? What is it? So, and this is naturally the ambiguity of language. It means something different in different contexts, but programming language is always precise. It always means one certain thing in a context, always. So, and when we come to extreme programming, so why you should care about that? First of all, I missed the headline, I see that. This is Kent Beck. You could call him something like the father of extreme programming. He was the main figure who made the concept popular. Of course, he was not alone. He was like any other great person in a big network of smart people, but he literally wrote a book about extreme programming. So, and what is his mission with that? It's very simple. He wants to help geeks to feel safe in an ever-changing world. right? And that is what we actually are. We are not everyday people which are doing everyday stuff. We are actually quite focused and quite narrow on what we are doing. And that is, you could say, a definition of geek, right? And we are living in an ever-changing world, and actually also in an ever-changing unsafe world, because how companies treating us are not really good, right? If you just think about that, you're always under threat to get laid off if you have a job in certain countries. I just say US. If they just can shut you off the system in 2 days, like it happened to lots of engineers in Twitter, or now X, right? Or Google just says 1 to another week, bye-bye. This is really unsafe, and this is something, he says, is a mission to counter that. And also the uncertainty which comes with that. So these are just some book covers which are very important when we speak about the topic, right? Extreme Programming Explained is mainly the base I use today, but there are much, much more. Test Driven by Example, also from Ken Beck, is a very important book, or Growing Software Programs with Tests is also very important. Anyways, just an aside, and when we speak about XP values, is communication one of the crucial things, right? We have to communicate with our team, with our stakeholders, with our surrounding every day, and that means we are not alone, and we have to communicate. Second, what we want is to build some certain kind of simplicity, some simple solutions for complex problems. We don't want complex solution which nobody understands anymore. We want simple solutions for problems. And simplicity is therefore one of the core values of extreme programming. Another thing we want to have is constant feedback. Right, we want from our customers always to know if what we just built is that satisfying their needs, or do we have to adjust it? If we are programming, is it correct what we are just done, or is it incorrect? This feedback loop in any matter or any circle you want or any context is very, very important. That's why it's also a core value. And we want to be courageous. We want to speak with customers directly, also as software engineers, because we as software engineers also have to have a product understanding. That's very important. A holistic view about what you are building is important, since it gives you meaning, and it gives you also the understanding how actually stuff fits together. And this is also something which companies these days don't really do, but it's important. And we want to also respect each other. I think that goes without saying. And lastly, there's a blank. Because XP also emphasizes there can be much more values, and you just can fill them up if it's not contradicting the others. That makes sense, right? So what are principles of extreme programming? So humanity, and this is really important because the first article Ken Beck ever wrote was about extreme programming is a method for humans. So humans are in the center, and when we come to the beginning back and say he wants to help geeks to feel safe in an uncertain world, he also says that human beings should be in the center of software development. That means their basic needs should be satisfied. They should have fun. They should have involvement in what they are doing, so that they are actually dedicated to their mission. So economics, of course, somebody needs to pay whatever we are building. So that means also, like, we should not waste our time. We should go efficient with our time and build what actually makes user impact and not just makes us happy as software engineers. This is also very important. We have to negotiate to a mutual benefit, which benefits us as software engineers and benefits the business, right? So what it means, for example, if we can make a case that if we make this refactoring and it brings you something in the long run to a customer, this is something we should do. If it's just something, again, which is just for us because it makes us happy, because it satisfies some certain sort of aesthetics, this is nothing we should do, because we then violate the mutual benefit. Sorry, I should talk slower. So self-similarity is also a thing. I won't explain that anymore. And improvement, because we also want to get better. So that our diversity is also important. There are much more. This goes on and on. We want to reflect, we want a certain business flow and a certain value flow. This list is very comprehensive. I actually took everything I found to that and put it there, and I just want to highlight what is actually important. So opportunity redundancy, for example, this is also a good point in your daily work, right? Somebody might argue we don't need to test stuff, right? Because we make a code review. But test in this sense also satisfied redundancy, because of course we want to make sure that we can automate what we see is right in the first place, but we need a second pair of eyes to verify that what we were thinking is really right for the business context we are working in, so that we have something which is backing us up. So we should also embrace failure. That means if we fuck something up, we should learn from it. And that I think everybody already knows or encountered in their career or life. Diversity we already had, quality, acceptance, responsibility, and baby steps, incrementation. This is very, very important. In opposite to waterfall, what we want is that we go step by step to come to a product. We don't have a product vision complete when we start a thing. We're just getting there, and we start with the smallest thing we actually know of. So what is really in front of us, and we are working us to a fitting product. So what are practices of extreme programming? First of all, sitting together, which means you can literally think of a big table where you sit maybe on Monday, Tuesday, Wednesday together with your team and speak about what is important and what are the goals for the coming week. So, and this personal contact, may it be virtual or in persona, is important, because through that you also forge relationships. And then also we come back to the value of communication. It's always about the entire team. It's also never about single persons. And we might know that. And each team might have something like a star programmer or a star product person. But in the end, they can as good as possible as they want to. If the rest of the team sucks, they won't deliver stuff. So it's always about the team as a unit, not about single persons. And this means you also have to accelerate people in your team, right? No matter if you like them or not, but you are fitted to them and they are to you. The next thing is, this is really hard. You should always be motivated and try to do the best you can every day. That doesn't mean you should burn out though. Quite the opposite. You should give not 120% every day, but 80%, because 20% you need not to burn out. So, but you should really try to and improve every day. Pair programming, you might have heard of that one. And who ever heard of user stories? Some people. Okay, user stories are also a thing which came with extreme programming. I will come to that later because they will play a role. Then we have weekly cycles. I won't go into that too deep. Like quarterly cycles, you might have heard of something like OKRs that goes in that directions. Give people slack, like if you plan a sprint or whatever unit you have for work in a time frame, leave some room that people can do some other stuff. So, for example, if you have a ticket which might blows up, you can compensate by putting a small ticket where you know people might do that in the afternoon, but so you have time to shift around. And also not to burn out people, that's very important. 10 minutes build, that's not so important anymore. Continuous integration, so you should actually try to not hold long feature branches on your machine or on GitHub. You should actually try to merge as soon as possible into your main branch, so that resolves a lot of problems like merge conflicts and so on, but people not tend to do that. And Git flow is actually an anti-pattern. Test first, so test-driven development is a thing, and that is quite important, and it will become more and more important with AI. I will speak later about that. And incremental design. Again, this is a thing. We don't want to do everything at once. We want to do it step by step. And it also helps us actually to deal with complexity and deals with assumptions, right? We normally might assume that X, Y, Z is, and we have then to do W, P, F whatsoever. And those requirements we set at the beginning might never come true. So I myself had been there a lot. So requirements changing, assumptions changing, and if you do only small steps with the things which are really ahead of your what you are facing. Then it's much easier to change direction or to overcome any new requirements which are coming in. There are other practices like, first of all, customers are part of the team. You should have them at least once a week or once in a cycle in your stand-up or in a special round so that you can communicate directly with them to understand what is actually their needs. Incremental deployment, I think that's also good. Team continuity, you should actually try to keep a team together and not tear them apart very often. That happens in some companies which say, for instance, we have a feature, the feature is maybe done in 6 months, 3 months, 3 weeks, and then we reassign the team with new people. That should be actually avoided because this actually disrupts social coherence and also social relationships. That's really important to know. And there's also a lot of studies about that. Shrinking teams, I will not speak about that. Root cause analysis is normally not really done in companies. That's very sad. Some of you might hear about postmortems. That's practice which also relates to that, but it's not really done very often in companies these days anymore. They just try to manage some symptoms normally, but not really try to figure out what is actually causing the issue. That can be engineers, that can be missing knowledge, but it's never just a technical problem alone. So, shared code, we don't need to speak about that. In code and tests, I said already something to that, like TDD is a thing, single code base, so you should actually speak always about one code base and not like everybody has on his logo machine their own, but this is these days I think not a problem anymore. Also, you should commit as soon as you can, so your teammates see what you have done. Negotiating scope contract. This is also very important. What I said already, you have your customers in your stand-ups, so you can actually speak with them about the requirements, what they have in head, what the feature should go, and actually what you can deliver in the time they give you for that. So these negotiations are very important because this is also expectation management, and it also helps your customer to understand that they might have the dream of this castle in the clouds, which is nice and golden and shit, but you can't deliver that in 2 weeks. That's simply not possible. And making them understand that and negotiate what is really important for the step ahead is the thing. And you should do that. And even if you are negotiating only with your product manager, but you should not just go and say, oh yeah, I have this ticket, that's 5 points and go. That's not the way to go. The thing is like, make the ticket at the moment sense. Is that what is described there something I can even deliver in the sprint ahead? Something like this. And pay-to-peer use, I don't go into that too deep. There are another related books which I can highly recommend, especially Accelerate. That's a very good one. I like it. Domain-driven design also everybody should have in their bookshelves. That's also a classic, and something else. I also really like modern software engineering from Dave Farley. That blew me away this year, and more. So this is just the advertising block. Let's come to the second chapter, and I take a sip. So, because the room is really dry and really hot, so, and so much talk. So, and as I already said, with the AI, a lot of things happened over the last 2 or 3 years, right? We all saw the posts on LinkedIn where some CTO says, oh yeah, we don't need programmers in 10 years anymore. And some other people which said, oh yeah, it will never happen, but where's the truth? So, and another thing I already mentioned is nobody speaks so much what is currently actually happening in research about that. And in this chapter, I want to speak a little bit more state of research. I can't go very deep into it, even if I want to, and the research is currently exploding over the last 6 months. More and more studies coming out with different qualities, but I also can just encourage you to sit down and maybe read some of those, because it will also give you some advantage when you speak with your boss, or when you speak with your CTO, or also for interviews, because this will ground you in reality where we really stand right now. And AI is currently everywhere, right? Felt like, and it really is. I just figured out now you can with Sono, or how it's ever called, even make your own music, which is great, but it's bad for some artists, I guess, except they are pop artists. I think they're already doing that for years. And you have something like Figma AI, which is really great to make designs if you want to try something out, but it's felt everywhere. So, and the problem with that is people have certain assumptions about AI. For example, they say like it's a tool. They don't really get it's a tool. It's not something which solves every problem. It's like with blockchain, right? We know the hype when it came to, just make blockchain and everything will be solved. This is right now the AI hype. It's slowly going down, but it feels like people not still getting that AI agents or assisted programming is more a tool and not a solution. The second thing is, like I already spoke about that, the situation with junior developers. AI can't replace people for a very good thing, because AI lacks a very important stuff, not to be biased. And one of the biggest strengths of junior engineers is they have a certain bias, but they are not like branded like people which are already for 10 or 20 years in the industry, which says, oh yeah, we did it 20 years ago like this, we did it 10 years ago like this, we have to do it today like this. They coming totally blunt into the industry and have to learn those biases, and that means they also force you to really ask yourself, is that still valid? Does that still hold up? For instance, when I joined my first real company, I will ignore the time. When I joined my first company, I, for instance, took a practice which was called Joda coding. You just swipe, for instance, the constants with the variable in a comparison just to avoid some errors, and people were totally baffled by that. But it was good because we had something to discuss about it. And this is actually the value of junior engineers. It's not about coding itself, it's about that they force you to think about, to learn again, and also to not getting old and grumpy. So, and AI is also not the messiah. And a lot of people don't really ask themselves, what is AI delivering, and can you believe that or not? They just take it and think it's right, but it's not how it works. So, and when we differentiate about AI, we can actually differentiate in 3 generations. We have code completion. You might hear of something like Copilot. That was the thing about that one. The second generation was about chatting with AI. You heard most likely about Gemini, and the third generation is something like vibe coding. You heard about Claude, I guess. So, and if we speak about AI or assisted programming, we mean any of those, but always one of those. That's a little bit complicated because certain stuff works in certain situations very well. So, and the first study just dropped last week, which I want to present. This is Dora. This is the DevOps accessibility report. This is done by Google Cloud. You can download it for free. It's a 200 pages book. Since it just dropped last week, I just have a small stuff to share about that, not so much, since I also didn't have the right time to digest it. So in 2024, they actually figured out that 60% of the programmers actually feel more productive with assisted programming. That doesn't mean that they are actually productive. And what they mean by feel more productive is like they get maybe productivity boost of like 10%. So it's not about this, oh yeah, I can be doubled as fast as I'm normal. No, it's just like a little bit small. And only a very small number of people actually reported that they are super much faster. So on the other side, what was also to observe that there's a reduction on delivery speed or delivery performance, which means like how fast you actually make an integration with your code base. This is a little bit counterintuitive if you think like you are faster, but then you ship slower. That doesn't really fit, right? And the next thing is like already 2024, 75% of programmers had some sort of reliance on AI. So, and yeah, the rest I think you can read. This is not so important, just to have some numbers. And 2025, the entire DORA report is just about that. They made some really nice observations. This is just a quote out of it. And let me go forward. First of all, now over 90% already have some sort of reliance on AI. 90 from 75 in 1 year. That's quite big and quite huge. So, and now 80% believe that they are productive. But the next thing is like, in terms of productivity increase, it's still like that most people don't get so much out of it. It's not like that they double their productivity, it's just like mediocre. And the next number is really important. Only 30% or 30% have very little trust in what the AI is producing, and almost 50% say, yeah, I can trust it somewhat. Somewhat means like 50%. It could be good, it could be bad. So, and this is not great. That means like whatever the AI producing is not something we can, without a doubt, set in production. That means we always have to work upon that. We always have to manage that. It's not like that we can close our eyes and it's good. And this is actually not what we want, because that means like it's not really helping with productivity, sadly. So, and on the other hand, we see like performance speeds goes up with the delivery. Oh, this second point is wrong, my bad. And the third point is also very interesting, that people think that a language syntax and language knowledge becomes more important with AI. How that correlates, I couldn't get out of the study, but this is just a very funny observation. So, and still like most of the participants of the study think like that the importance of other skills, which you normally needed before AI, is still the same. That didn't change. It's not like that you can get rid of something. No, no, no. You just learn something with AI on top. So, and one conclusion out of the DORA matrix is that AI these days could be seen as a standard already. It's not like something you might want to do. It's something you have to do because it's already industry standard. And many companies actually enforcing that. And this is another problem, that AI adoption is driven by more social pressure than actually curiosity. And that the success of that is really depending on the surrounding technical and social culture. Like if you have a company which doesn't know how actually to deal with AI, and they can't really help you with that, you won't succeed. If you have a culture which, like a company in Germany says, you have to use AI or we quit you, that leads to a point where they lay off maybe 30% of their employees, but their stock goes down because out of a sudden nothing works anymore. And that really happened. So, and the next thing, the DORA report also states that teams have to learn actually to evaluate the output of AI. And companies should allocate time and budget that teams can learn that. Next study, this is also a very important one, AI Copilot code quality, because it shows us others the state of the usage actually. And these are the actual numbers. So here we have 2013. Here we have the year of the year change from the year before, 2023. So, and one big number is this one, which is really interesting, and also copy, paste, and edit. What those numbers mean is actually what we see, that there's a decrease in refactoring of code. So we can observe that because why is that? Because we're adding more code than we are deleting normally. And that is normally a sign that we do not really a refactoring, we're just adding code. So, and what it also means, like we are starting to see more copy pasting. And this is something we see over the last 2 years already, in opposite to the time when there was no AI available. And also what we see is there is an increase of rollback of code bases. And that's really dangerous. That means like the quality goes down. That means also the code is not really stable what we are shipping. And that's really sad. And 2024 was the first year that we see that more code was copy-paste than moved. That means like that refactoring was less than actually copy-pasting. And we all know copy-paste means we have to maybe maintain code twice, 3 times, 4 times. However, how often we actually copy-pasted that piece of code. That's something we actually don't want to have. So the next study, and this is a really nice one because this is a bigger one with over 200 people, 200 participants, and this in those study, mostly IT professionals participated, not students, as you see it normally in studies. And this was together done with a research team and some consultancy, equal experts, where also Dave Farley, for instance, is a member of. And what they figured out is that there's not really a big differential in productivity. So completion of a task is not really tied if I use AI or not. But if I have somebody who is proficient with the tooling, they get actually a speed up to 12.5%. And that is important. You need to be actually skilled in using AI to actually leveraging it. And the assumption what you hear from most company, oh, you don't need any knowledge with AI. You just get the acceleration out of the box. This is simply not true. So, and people who are actually using AI proficiently and be productive with that feel less productive. That's also super counterintuitive. So why that is, it's hard to tell. So, and assisted programming is also prone to certain problems. Like what they tend to do is doubling code size, or you might have seen that already, like the output is always very verbose. They're putting comments in that, which are mostly not really helpful. And on the other side, it can also deal with other problems. AI is actually quite good in separating layers from each other. So they will actually separate something like a data layer from a business layer, from a UI layer. Very good. I'm super over time. I'm super sorry. If you can't do anymore, just let me know, then I stop. Because the topic's really dense. I know that. And I am a little bit slow today, and that's why I'm going super over time. So if you want, I can also stop here. If you are still up to the task, I go on. So I go on. Yes? All good? So, and the room is not really good for breathing. I know that. I'm super sorry. I already spoke about that. Assisted programming actually exceeds the code which is generated of that. It blows that basically up. And as you know, if you're already working, there's a sweet spot where you have certain code sizes and a certain verbosity in code and the value you are shipping. Like what you don't want to have something like function 1, function 2, function 3 as naming. You want meaningful names. That is already a certain size of verbosity. But what you don't want is like names which go this long, then you have this long of a comment over it, and then the code in between is this long as well. And the last one is more done by AI. Humans tend to try to keep it short as much as possible, but they still understand what's happening there. So, and AI can't, or assisted programming can't really deliver that. That's something which they also prove. So, and what is also seen through the study, that the understanding what's happening in the code base shallows more and more, especially if you have people which only using prompting and not actually writing code anymore. And this is really dangerous, especially for people which just starting in their career. So they don't really understand what's happening. And this is something we have to keep in mind when we think about how we need to educate the next generation. And for us, which are already longer in the industry, there's a risk that we're actually eroding our existing skills. Like if we are good in some certain programming practices, if we don't practice them, they go to nuts. Oh, sorry. they go to nuts. So, and there's a MIT story which also showed that our logical center in our brain is actually eroding with too much AI usage because we're not really using that. And the brain is like a muscle. It needs some exercise to actually work properly. So, last study, and this is from a very, also a very important one because this is very often quoted from a Mr. Mock. There's a really funny joke about that. And they had something of a very small size on when they conducted the studies. I think they only used like 10 or 20 people to conduct it. So I would treat the study with caution, but if you look in the quotations, this one is really influential. So first of all, what I figured out that non-technical people are actually very often misled by assisted programming or AI. And you might have seen that some of your project managers already go and say, oh yeah, I did this prototype with this AI agent and it just works. And they don't see that this is just what it is, a prototype, and they can't exceed that. So, and they also don't see the flaws. So, but they also see like that assisted programming is something engineers can use as an augmentation of what they are doing already, to actually also accelerate them, but it will not replace them because programmers themselves bring a sort of creativity into the mix. And what works fastest, surprise, is when you automate the entire development circle through AI, but if you automate that, it has the lowest quality. That's also very unsurprising, and there's much more in the study. So, and what I see as from my observations is like what really matters for assisted programming is the context where you are in. It depends if you're doing Android, if you're doing web, if you're doing backend. It has a certain quality of that. Assisted programming is really, really good with web programming. I give you that. It's actually quite amazing, and you can automate so much with that. When it comes to Android, on the other side, I'm really disappointed on a daily basis. Like, if you lose, for example, Gemini, it can't really deal, for example, with Hilt. So try to write some tests with Hilt and with Gemini. You will simply fail because it can't do that. So, and also if you do backend and you do something like with Spring, it can't really deal with modern Spring because it didn't see the documentation yet. And it will always refer you to Spring versions 2 or 3 versions in the past because there the documentation corpus is the largest one. And it's super annoying because it interrupts your workflow. So, but if you have a certain project structure and if you have a certain helpers for your AI. I think the next talk will also speak about that. This becomes better. For example, if you have self-enforcing architecture, AI can deal much better with each task you give it. And what I mean with self-enforcing architecture is something, and you might know that, where you can't really break out. Like if you use something like Redux on web, or if you use something like MVI on Android, it's hard to break out of these patterns. It's reinforcing itself. And AI, if it's trapped in there, can actually deal quite well with some stuff. And also, the next bigger problem is how we actually verify what the AI, or is the AI put right or wrong. So, and where AI works well is if you do bigger steps and not small steps, because AI can't really deal with iterations. That's really sad. Also, like AI will be amazing at tasks where you would be amazing, but you're just too lazy to do them. Like if you're writing something like test dummies, where you simply use random values in it, you can use AI. It's actually quite good generating them. Or if you have to generate some fakes or stuff, it's quite good for that. But the complex your stuff get, the worse the result of AI gets as well. And that's why I have this with me. AI is also good as a mental health, because what you can do is actually speaking with your AI model. Normal computers today have something like a voice interface, and you can wire your voice interface directly into the chat, and I work remotely at home. That means I'm working against my white wall. And that gets sometimes really sad, really boring, and you have nobody to talk because nobody is on Slack. What you do? You can just use your rubber duck. You speak against the rubber duck. You just switch on your voice interface and speak with the AI agent. With some certain new models, like I forgot the name. With some different models, you get even voice over response. I know I have to stop soon. So, and actually that helps also with your mental health. Myself, it keeps me sane. So, but also what assisted programming inherently is it's biased because you always get very certain responses because AI agents are trained on human code, and human code has certain biases in it. And these biases are emphasized. There are certain studies also about that. And it's important to know that, and that's why you should also not handle AI as a base of truth. And I already said that a natural language is imprecise, it's ambiguous, and we communicate with AI through natural language. That means, like, we actually want to have a precise result throughout something imprecise we communicate. And that's why also the output we get from AI models might be imprecise. So, and we should also not forget about that. And AI by default is also very monolithic. It always tries to generate everything at once. It can't really do a step by step. And that's also a really big weak point of it. So, and some side notes for this chapter at the end, like, first of all, AI will always cheat you. We just this week did something, and AI should just make some tests pass. And what AI actually did is it just deleted some stuff out of the test and not actually change the production code. And that happens on a daily basis, right? It will cheat you, no matter what. The other thing is, like, also don't try to actually generate out of AI tests. That will not work exactly for the same reason. It will try to make the test green no matter what. It will not check if what is done there is correct. It doesn't know what you actually want to prove with your tests, and therefore it's totally meaningless to actually generate tests out of your production code with AI. And AI is more like also already working as a catalyst for problems you already have. So as I said, it's trained over the corpus of code which is done by humans. And in those kind of code blobs are already some human problems encapsulated. And this is trained over and over and over again. So this will also come back if you use it again. And that's why it's also a catalyst for some stuff. AI costs money and it costs energy, and it's not cheap. We should also not forget about that. And the results you get are never the same. So you can't even rely on that if you run the same prompt twice, that you get the same result, even if it's in the same context. So this is, for this chapter, my closing questions. Batch size is increasing. I spoke about that, how to deal with that. So how to deal also, like, that we get more alienated with our own code base. That's super weird. What are actually the consequences for product, and also what we teach the next generation, and what is also the impact on the team structure. So last chapter, then we did it. So how we can actually now bring the first chapter and this entire with XP practices and this AI thing actually together. So the first thing what we should not forget, XP is a mythology. It's not like a very concrete toolbox. So, and this mythology is actually designed to deal with complexity. On the other side, AI causes some sort of complexity, right? So it should fit very nice together. So we need also some skills to do proper XP. We need some skills to do proper AI. So we could think about skilling them up together, right? And something like TDD is actually meant to build some very specific, very precise specifications, patterns, whatsoever for products. And those specifications can be consumed by an AI model and actually does the right thing. So how we also get that together. And last thing we also need is version control and stuff. So yes. So how we can bring that together on a test-first basis. So how we can bring it together with TDD. When we speak about unit tests, AI is actually quite shit. For a very specific reason, the computation of an AI model takes simply too long. There's a golden 10-second rule. You should be capable to do any step in the test-driven development lifecycle in 10 seconds. AI model, regardless of your internet connection, will take longer than that. So it's not really usable. That's really sad. And the next thing is, like, if you want to have certain approaches, it also doesn't really work because it has always this very creepy bias regardless of the model. You can try it with Gemini, Claude, Cursor, whatsoever. It always wants to use mocks, for example. And this is not good because not every project, not every context should use mocking, right? And even weirder, if you say, oh yeah, I have this very nice test set, please generate me some production code, it sometimes even tend to ignore that. So it's not helping, that's really sad. But if we go frameworks, yeah, it also can't really deal with something with HILT. But if we go a little bit higher, if we make the step bigger, it actually gets much, much better. So acceptance testing or acceptance test-driven development, where you write something like acceptance tests at the beginning, which covers a big portion of the system, and then you start using AI going down from there, actually works quite surprisingly well for main cases, not for edge cases though. So the larger the step and the more black box you also can provide the AI, it's getting much better with the results. It's also very surprising in my observations. So, and if you look at like this picture is also produced with AI. That's why there is this a nice little misspelling of productivity. And I can tell you, I tried several times to get the right spelling. It doesn't want to spell it right. So normally, like if you go the test pyramid from bottom up, tests get actually more expensive. Testing gets more expensive. But on the other side, AI, if you use it more up, it can perform better. So you get actually quite a good benefit out of there if you use that. And how that can actually look like is we come back to our user story I mentioned at the beginning, right? A user story is simply just plain language to say, I have something like an actor who they want something, and then I can state there what they want, and then I also should state why that matters. That has several reasons why that matters to them, and that's important. And through that, we can do then something else, which is called example mappings, where we actually then go and make some example scenarios for the use case. So this is an example we could say as a returning customer. So I use maybe the service twice. I want to have an account because I want to store some data. So I can then trustfully purchase a data package. That would be something which goes for Airalo. So, and I can then go and say, and I take this and generate me Gherkin. And Gherkin is a specification language. Gherkin is very precise. It's almost programming language style, but still in a natural language format. So that means you can also go with Gherkin to a product manager and speak about that. And the feature is something like a bigger scope, right? Which encapsulates then this part of the user story. So, and the next step is then that I can, out of the scope, then generates different scenarios. This is just an example scenario, and this is all created with AI. I just gave it that thing and got, for instance, that out. And as a last step, this slide I had to do in black because my IDE is black. As a last step, I can then take that and use that to generate something like Cucumber, or for Android, Maestro, for a test framework out of that. And in this way, I automated already some sort of my QA. As I said, it's not really good when it comes to edge cases, but the main cases, so 80% can be covered by this. And that worked surprisingly, amazingly, really good, out of the box, without even telling AI something to do on top of that. This is one thing. The next thing is pair programming. I already said that I actually speak with my rubber duck. So the better question, can I use AI really as a pair? And I would say, it depends. in pair programming, you have actually the capability that your pair gives you direct feedback, be it that you are the driver or you are the navigator. But the other person will say, oh, you do shit here in a very direct way if you have a trustful basis. And the AI can't really, doesn't really has a persona to bring you feedback that you also really understand and also you take to your heart. So in this case, it's a little bit questionable. Also, as I already said, AI is biased, so it always also repeats their bias very heavily, even if it doesn't make sense. And in this sense, it's also not very good for pair programming. And depending on the context, you never know what I mentioned already with Spring Boot, if the knowledge base it actually quite currently has is enough or is up to date. And that can be really annoying because then you try something out and that costs you hours and you just lost the hour because you trusted AI as a navigator. But on the other side, as I said, speaking with an AI model can improve your mental safety, at least from my perspective. So, and some wildcards, and this is also out of the field. Like one of my good friends, he has a completely automated generation process where he goes, mostly he's a CTO, he works in finance and so on, and he's also a TDD practitioner. And he automated his entire feature creating process. He has a meta agent with Claude, where he has some Claude hooks, and there are some other AI agents included, and through that he generates overnight entire features. So, and because it takes longer to execute the plan, and funny thing, for example, he pays the max plan for Claude, it's 200 euros a month, but he burned last month like 7K worth of token. Because he uses so excessively. And what we can observe through his method is that he really gets a lot out of it because he does work alone what a normal entire team would do overnight. It's really amazing. He basically generates some code overnight and sits in meetings over day and just reviews it and makes some correction to it. And that's quite genius. I wouldn't say that works for Android, but in his case, that works. And there's a misspelling, it should be live with V. So also imagine maybe the scenario that you sit with somebody from, with your customer in a call, right? And they ask you if you can show something live, if you change maybe that feature. And for example, if you use Figma, the Figma agent, you can actually do that quite easily. Figma already has some prototyping in it, and the Figma agent makes it very easy to also change it into a prototype where you can then show your customer right away and then discuss if that is really what they want or if there should be some changes. So, and also like think about what is missing if you have a designer. Or if you don't have somebody who is product, maybe you can fill that up also with some AI agents. So, and now to the conclusions, and then I'm really done. I'm sorry that I really overtime. Yeah, I'm super over, I know. So what we see right now that assisted programming is really a disruptive change to the industry, and there's no way around it. So as I said at the beginning, and we should embrace it and not try to dodge it like some people try to do. The good thing what we are seeing that programming itself changes. It's not about really like with UI programming that we tell the UI exactly how to do some stuff, sondern that we declare the results of stuff. We go into declarative programming more and more, and not in how it is like this still like imperative programming. And this is really nice to see. And also the roles of a tech person and of a product person coming closer. You as a software engineer, you can't rely solely on your technical skill, but also you as a product person can solely rely on your product skills. So almost last slide. So we still see a dilemma between assisted programming and humans, because on the one side, AI is really good when it comes to generating big batches. On the other side, that's not how our human mind works. We tend to do smaller steps, and we need those smaller steps to tackle actually the complexity. So how this comes together is also, for me, still a big question mark. So we also need still to figure out how we can keep the fun into AI programming, because this is also what research shows, that fun goes away. And I think like extreme programming and AI is a match made in heaven and hell at the same time, because in some aspects it's really great, in some aspects it just sucks. So, but in the end you should try it nonetheless. And the future for our programming, I think, is exactly that. Programming still stays the same. It's still identifying and solving some problems with code. But the code is maybe nothing we do that often anymore. If you want some feedback aside from I gone over time widely, I know, you can do that. No. And with that, I'm done. I'm super sorry that I dragged you so long here. So with that.